so we're going to go over the elements of a simple curve. Some of the things you want to take a notice of is the line coming in, straight line coming in, and a straight line coming out. I'll go through each one of these. We've already talked about the radius, and we've already talked about the degree of curve. We've already talked about the length of the curve, but we'll start breaking these down individually. So the first thing is the PI, the point of intersection. The point of intersection marks the point where the back and the forward tangents intersect. So straight line coming in, straight line coming out. This point where they touch is called the PI, the point of intersections. The surveyor indicates it as one of the stations on the preliminary traverse. So when they actually stake these things, they'll actually stake the PI point, the PC point, point where it starts to curve, and the PT point where it starts to come tangent back out. The intersection angle is the intersecting angle of the deflection from the PI. So I have a straight line coming this direction and a straight line coming back out. Where those two points intersect is the PI. But the angle that makes between those two straight lines is the intersecting angle. The surveyor either computes its value from the preliminary traverse station angles or it's measured in the field. Okay? Now, you also have the radius. Basically, this radius is forcing what that angle is going to be in there. Okay? The point of curvature, the PC, is the point of curvature is the point where the circular curve begins. The back tangent is the tangent of the curve at this point. This is called the back tangent because the PC starts here, it's behind it, the back of it, and the PT is the point of tangency. Now, the point of tangency is the end of the curve, comes around and stops. And then it has a forward tangent where the straight section starts over. Now, this is traveling from left to right, okay, in the roadway design. So station 10 plus 00 would be here, and 20 plus 00 would be over there. Now, if you were coming backwards, if you were traveling right to left, the PC would start here, and this would be the back tangent, and the PT. So it can be in different directions. I typically, not all engineers do this, I typically go and have my plans reading left to right like you normally read. Now you've got the length of curve. The length of curve is the distance, the arc length distance from the PC to the PT. The LC, the long chord, is the chord length between the PC and the PT, the straight line. The tangent length, so when you have a PC starting, so I got a straight line, hit my PC, and then it hits to the PI. PT, from the PI to PT, those straight lines are called tangent lengths. The tangent distance is the distance along the tangent from the PI to the PC or PT. These distances are equal on a simple curve. Now, only for a simple curve. Okay? E is the external distance from the line of the curve to the PI. Okay? It's to the midpoint of the curve to the PI. The external distance bisects the interior angle at the PI. The delta, sometimes you'll see homework that has a delta sign, and sometimes you'll see it with an I. The I is the same as the intersecting angle. The central angle is the angle formed by the two radii drawn from the center of the circle at O. O is basically your origin point to the PCs and PT. The central angle is equal in value of the I angle. So you've got a delta here and an I up here. These are the exact same. Okay? The M is the middle ordinate. So if I draw a straight line for my long chord, the middle ordinate is the distance from the midpoint of the curve to the midpoint of the long chord. So midpoint of the curve to the midpoint of the long chord is your middle ordinate. The extension of the middle ordinate bisects the central angle. Okay? Now, I'm going to pause here and then we're going to go over some of the math on how the horizontal curve formulas work.